Number 26. Consider the orbit of Mars around the Sun. The distance from Mars to the Sun at perihelion is 206.617 times 10 to the 6 kilometers, and the distance at aphelion is 249.229 times 10 to the 6 kilometers. Find the eccentricity of the orbit of Mars. So right here I have an ellipse, and if we draw out the axes, this is our major axis, and this is the minor axis. So the key piece of information you need to know for this is that the Sun in an orbit is going to be one of the foci of your ellipse. So the Sun is going to be like right here. So these two things, the perihelion and the aphelion, the perihelion is like the nearest approach of the planet. So in this case of Mars. So right here, this is going to be perihelion. And over here, this will be aphelion. So if we want to find the eccentricity, what we have to do is find the length of we have to find the focal length, and then divide that by the length of the major radius. So the focal length is just the distance from the center to the focus, so this length right here. And then the major radius is just one of these lengths. So this, or just the distance from the center to one of the vertices. So the way we can do this, so we have two pieces of information. We know the two lengths. So to find the total length, we can just add these together. And then to find the major radius, we can just divide it by 2. So if we add these two together, 206.617 plus 206.617 plus 249.229. Oh. 249.229. So we get a total distance between perihelion and aphelion of 455.846. And so that would make the length of the major radius just half of this, or 227.923. So A is 227.923. So if that is the length from the center to the perihelion, and the perihelion is 206.617 kilometers away, so that's this distance. So we know this is 206.617, and we know this is 227.923. Then this distance right here, the focal distance, is just the length of the major radius, or A, minus the distance at perihelion. So C will just be 227.923 minus 206.617. So let's see what that comes out to. So minus 206.617. So we get a focal length of 21.306. So C equals 21.306. And then finally, to find the eccentricity, you just take the focal length and divide by the major radius. So E equals 21.306 divided by 227.923. So 21.306 divided by 227.923. So we get 0.0935. And that is answer choice A. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.